Welcome back to Practical AutoCAD and Inventor and our series on preparing for the Autodesk Inventor Certified User Exam. In this video, we'll walk through how to place external threads on cylindrical surfaces using Inventor's Thread tool. We will start by identifying the types of cylindrical features that can accept threads, then demonstrate how to use the thread dialog box to specify thread types, sizes, and lengths. We'll also talk about cosmetic threads and what Inventor represents versus what gets manufactured. By the end of this video, you'll be comfortable placing external threads and confident in applying this tool both in the exam and on your own designs. Welcome back to Practical AutoCAD and Inventor, your source for solutions to your problems with AutoCAD and Inventor. If you like these videos, please like and subscribe so you will be notified whenever new videos are published. Also, if you have any questions you would like me to answer, please leave a comment below. Now, on with the video. The Thread tool in Autodesk Inventor should only be used for placing external threads on cylindrical parts and not internal threads on holes. It can put internal threads in holes, but the better way to put those threads in there is by using the hole tool and all of the thread tool or the thread tools that come with the hole tool. So when you want to place threads on external parts, what you'll want to do is model your part the way you want it to be. In this case, I've got this simple part here. If we look at it from the side view here, you'll see that I've got one end of this is cylindrical and the other end is conical. So it's tapered a little bit. It's smaller at this end than it is at this end. When you're ready to put your threads on, it's actually quite simple. What you'll do is you'll make sure that you're on the 3D Model tab up here at the top. And then on the Modify panel, you will come up here and choose the Thread tool. Once the Thread tool comes up, it's basically prompting you to select your input geometry. What surface do you want to put the threads on? So I'm going to start off and I'm going to choose this cylindrical surface over here. And you'll see that it simulates the threads in, okay, showing me what they're going to look like. But the other thing it does is it gives me a whole bunch of options right here. Now what it did is it measured the diameter of my drawing, and it recognized that I had modeled this with a 3/4 inch diameter. So it says, okay, do you want the ANSI unified screw threads with a 3/4 inch diameter? That's a 3/4 tin UNC with a 2A fit. So all of these things have different meanings. There are several different types of threads. ANSI screw threads are probably the most common, but then you've got the metric profile, you've got ISO, you've got tapping, threads, all those different types of threads depending on what you're doing. So you can simply choose the type of thread that is appropriate for your application. And then you could change the size, but I don't recommend it. Again, I drew this shaft the right diameter, so it's recognizing that I need a 3/4 inch diameter. If I were to come back in here and say I want a 1 inch diameter, you'll see that it changes my outlook here, but then it's saying it's a 1'8", but the diameter of this is really only 3/4. So I don't recommend that you do that. I just say come in here and let it put the threads in the right size because you've already modeled it the right size. The other thing that you can change here is the designation. You can change it from the Unified National Coarse thread to the fine thread or any of the other thread options that you have here. The last thing that you can change, or the last two things you can change, are the class. So this is the tolerance. How close does it need to be? Is it super fine tolerance where it needs to be really close, or is it just average, or is it loose? You can change those, and you could also change them from left-hand threads, right-hand threads to left-hand threads. The other thing you can do is you can say, I don't necessarily want threads on the whole thing. Let's say I only wanted threads, on part of this, but I didn't want it, say, for the last 1/4 inch. If I click on this little side arrow right here, then I can say I want my offset to be 0.25, and you'll see it's measuring 0.25 of an inch back from this direction. And when I choose OK, then I don't have the threads on that last portion. So what we get here in this model are what we call representational threads. It's just a picture of a thread applied to the model here in Inventor, and they do that simply to save computational space. it could go through and actually create those threads, but then you end up with a part file that is very, very large, and it can cripple some computers, especially when you've got several parts with threads in them in an assembly. So they put this thread representation on there, and it's acceptable in most situations. Now, if we look at the drawing itself, come over here to the drawing, you can see what it does is it has the outside lines, that's the major diameter, is shown with a visible line, and then the hidden lines here represent the minor diameter. That's the bottom of the thread. And this visible line right here represents the ends of the threads, and this is exactly the way it looks in technical drawing. So you can go ahead and put those in there. And you'll see, of course, if I go to the Annotate tab and I say I want my hole and thread notes, as soon as I pick this, it recognizes what that is, and it says it's a 3/4 tin UNC 2A fit. So it embeds all of that information intelligently into the model so that I don't have to remember what it is and go back and fix it. The other thing that you can do with the thread tool in Inventor is you can apply threads to a tapered surface. Again, this surface right here is tapered. You might be thinking, why would I want to do that? Well, pipe threads, for example, are tapered so that the tighter the more you thread it in, the tighter it gets, and it makes a good seal for liquid and gaseous situations. The process is the same. I go back to that thread tool up here on the Modify panel, and I pick my cylindrical surface. And then notice again that it's coming in here and it's giving me that option, and I can say I want it the full depth this time, for example. If I wanted that to have the full depth, I can choose OK, and it places it in here, and it also puts it in here into the drawing. Again, this is the proper way to do it. And if I say I want my thread and hole notes, I can simply pick that, and now it tells me that it's the 3/4 14 national pipe thread. So then finally, if you do want to put something like a chamfer on the edge, it's best to put that chamfer after you've put your threads in. So if I wanted a chamfer on here just to make it easier to thread, I'm going to say maybe a 1/16 of an inch chamfer on there. I could put that on and say OK, apply that, and it puts it on there. You'll notice that it fixes the threads a little bit and makes it all look the way it's supposed to look. So great way to plate your stuff in there, and definitely something that you're going to need to know for the user exam.